Light feels harmless. It fills your room in the morning. It reflects off walls, off skin, off glass. It makes colors visible and edges sharp. You flip a switch and it appears instantly. You close your eyes and it disappears from experience. Nothing about it feels mysterious. It behaves, it obeys. It simply illuminates. That familiarity is the first illusion. We treat light as a passive background feature of reality, something that allows us to see other things, not something that demands to be examined itself. We notice objects, we notice motion, we notice shadows, but the light making all of it possible fades into conceptual silence. And yet, every time light moves, something extraordinary is happening. When sunlight travels from the surface of the sun to your eyes, it crosses 150 million kilometers of space. It leaves a fusion reaction deep inside a star, escapes the sun's gravity, traverses emptiness, slips through Earth's atmosphere, reflects off surfaces, and finally interacts with molecules inside your retina. All of that unfolds seamlessly, invisibly. We summarize it with a sentence. Light traveled here. But what does that actually mean? We imagine a tiny particle flying in a straight line, or a wave rippling forward through space. Something neat, something orderly, something continuous. The mental picture feels clean and manageable. Reality is not that simple. Even before relativity or quantum mechanics complicate the story, light already behaves differently from anything else in your daily experience. You can outrun sound in a jet. You can accelerate a car, a rocket, a particle. But light does not negotiate its speed. It does not gradually build up momentum in the way objects do. It simply exists at its limit. That alone should feel strange. Everything else in your world seems scalable. You can move slowly or quickly. You can push harder and go faster. Motion feels flexible, but light arrives already at its maximum. There is no intermediate state where it rests. There is no slower version of it drifting gently through space. It appears constant, effortlessly so. The deeper illusion is that constancy feels normal, because we are adapted to it. Your nervous system evolved in a world where the speed of light is so large compared to human motion that it appears instantaneous. Flip a light switch, and the room brightens without delay. Speak to someone across a table, and the reflection reaches them immediately. Nothing in daily life exposes the structure underneath. So we mistake invisibility for simplicity. But the fact that light feels ordinary does not mean it is. Every time light reflects, it is interacting with charged particles at the quantum level. Every time it moves, it is obeying constraints built into space-time itself. Every time it arrives somewhere, it has navigated a reality governed by rules far more subtle than straight lines and simple waves. We do not notice this because the outcome is stable. The world does not flicker unpredictably. Objects appear where they should. Shadows form reliably. The sun rises consistently. The stability hides the complexity. What you call seeing is the result of electromagnetic fields oscillating, interacting, interfering, and obeying geometric limits that define the structure of causality. That sentence sounds abstract, but it describes the most common experience you have. You are immersed in something profoundly structured. The unsettling part is not that light is complex. It is that its complexity is constant, happening everywhere, all the time without ever announcing itself. It performs its deeper role silently, allowing you to believe the world is solid and continuous. And that silence is deceptive, because if you slow down and examine what light is actually doing, not how it appears, but how it behaves, you begin to see that the simplicity is only surface level. Beneath it lies something probabilistic, geometric, and deeply constrained. Light is not just illuminating the world. It is quietly revealing how the world is built. And the reason you were never meant to notice is simple. At human scales, the strangeness averages out. The weirdness cancels itself into order. The complexity resolves into clarity. But once you look closely enough, the illusion begins to thin. And when it does, you realize light has been doing something extraordinary all along. If light were truly simple, its motion would be simple. It would leave a source, travel in a straight line, and arrive at its destination. Clean, direct, efficient. That is the picture we carry in our minds. A beam tracing the shortest distance between 2 points. And most of the time, that picture works. Shine a flashlight across a dark room, and the beam appears straight. Aim a laser at a wall, and it draws a clean dot. Everything about the visible behavior of light reinforces the idea of direct travel. But when physicists began examining light at smaller scales, something deeply unsettling emerged. Light does not take a single path, according to quantum mechanics, and described with striking clarity by Feynman. Light explores every possible path between 2 points, not metaphorically, not approximately. Every possible path, the straight line. The slightly curved line. The wildly looping detour. Even paths that swing outward before returning. If there is a way to get from point A to point B, light accounts for it. At first this sounds absurd. How can something travel every path? That seems to violate common sense even more dramatically than relativity did. But here is the crucial detail. Light does not choose one path ahead of time. Instead, reality calculates an overall outcome from the contribution of all paths. Each possible route contributes a tiny amplitude, a probability wave, with a specific phase. These contributions interfere with one another. For most paths, the phases cancel out. The zigzags and detours destructively interfere, erasing their own influence. What survives is the path where neighboring possibilities reinforce one another. The path of stationary action, which often corresponds to what we perceive as the straight line. The straight line is not chosen because it is preferred. It emerges because all other possibilities cancel themselves. This is the hidden operation happening every time light moves. When a photon reflects off a mirror, it does not bounce like a billiard ball. It explores every conceivable route to the mirror and back. The angles we observe, angle of incidence equals angle of reflection, arise from interference patterns among possibilities. Order emerges from cancellation. This is profoundly different from classical motion. In classical physics, an object has a trajectory. At every moment, it occupies a definite position and follows a continuous path determined by forces. In quantum mechanics, the trajectory is not fundamental. The outcome is fundamental. Feynman quote, "Formulation does not describe a photon deciding which road to take. It describes a universe in which all possible histories contribute to what ultimately becomes real." That idea is easy to misinterpret as chaos, but it is not chaos. It is structured probability. At large scales, the cancellations are so complete that only one path effectively remains visible. The wild fluctuations average out. The improbable routes neutralize one another. The world appears stable and deterministic. But beneath that stability lies a constant calculation of possibilities. Every time light travels from the sun to your eyes, it is not sliding cleanly through empty space. It is participating in a quantum summation across an unimaginable landscape of paths. Most cancel instantly. A narrow corridor of reinforcement remains. And that corridor becomes the beam you see. This is why the simplicity of light is deceptive. What looks like a straight line is the residue of interference. What appears deterministic is the statistical outcome of deeper ambiguity. The unsettling implication is that reality is not unfolding along a single inevitable thread. It is resolving from a field of possibilities. Light makes this visible because its quantum behavior cannot be ignored. Unlike larger objects, photons exhibit wave-like interference effects even when emitted one at a time. The probabilistic structure does not disappear at low intensities. Even a single photon carries the signature of many paths. This does not mean light is conscious or making decisions. It means the framework of physics does not assign it a single classical trajectory. Instead, reality computes outcomes through superposition and interference. We do not notice this because at our scale, the mathematics produces stability. The improbable cancels. The likely reinforces. The strange smooths itself into the ordinary. But the smoothing does not erase the underlying mechanism. Light is not moving cleanly from point A to point B. It is sampling possibility. And what you perceive as a beam is the quiet agreement among countless alternatives. If that feels unsettling, it should, because it means the straightness you trust is not fundamental. It is emergent. And if even something as familiar as a beam of light is born from hidden layers of probability, then the surface of reality may be far thinner than it appears. Up to this point, light has already disrupted two comfortable ideas. First, that motion is simple and deterministic. Second, that a straight path is fundamental. But the deeper disturbance has not even begun. Because once you follow light far enough, you are forced to confront something far more intimate than motion, time itself. We experience time as a steady flow. It moves forward. It separates past from future. It gives events order. You remember yesterday, You anticipate tomorrow. The present feels universal and shared. That experience feels undeniable. Yet light does not participate in that flow. According to relativity, as an object moves faster and faster, time slows down for it relative to stationary observers. This is not philosophical language. It is experimentally verified. Fast-moving particles decay more slowly. Atomic clocks on airplanes tick differently than those on the ground. Time dilation is measurable. Push that acceleration further. Approach the speed of light. Time slows more. Approach even closer. Time slows further still. At the exact speed of light, the mathematics reaches its limit. The time experienced along that trajectory collapses to zero. For light, there is no passage of time between emission and absorption. This is the point where intuition falters completely. Imagine a photon leaving a distant star a billion years ago. It crosses interstellar space. It drifts between galaxies. Eventually, it strikes a telescope on Earth. From our perspective, that journey took a billion years. From the photon's structural position in spacetime, there was no journey, no waiting, no duration. Emission and absorption are directly connected by a path with zero proper time. Light does not age. It does not experience delay. It does not move through time the way we do. This is not because light is mystical. It is because of geometry. Spacetime combines distance and duration into a single structure. Massive objects move through this structure at angles that include both space and time components. Light moves along the boundary, the limit where spatial motion consumes the entire structure, leaving no component available for temporal progression. In simple terms, light does not trade motion between space and time. It exhausts the available structure entirely in one direction. That is why it cannot slow down. To slow down would mean reclaiming some motion through time, which would require acquiring mass, or changing its fundamental nature. The geometry does not allow it. This reframes something profound. When you look at a distant object, you are not seeing it as it is now. You are seeing it connected to you by a light path. That path defines the relationship between events in space-time. The delay you experience is not something light feels. It is something you feel because you move differently through space-time. Your sense of duration is tied to mass, to rest frames, to the slow, steady tick of internal clocks governed by atomic structure. Light has none of that. The unsettling part is this. Time is not universal. It is relational. Different observers carve space-time into slices differently. What is simultaneous for one may not be for another. What is distant for one may be connected for another. The ordering of events depends on motion. Light defines the boundary of that ordering. Every event in the universe has a light cone, a structure dividing what can influence it from what cannot. Inside the cone, cause and effect are possible. Outside it, no signal can travel quickly enough to connect events. Time, as we experience it, is simply the path we trace within those cones. Light traces their edges. Time. This means the flow of time you trust is not a universal river. It is a perspective carved from space-time's geometry. Light exposes this by occupying the limit where time disappears entirely. And yet, because we cannot move at light speed, we never directly experience this boundary. We are confined to slower paths, where duration feels steady and absolute. So we mistake perspective for structure. Light quietly contradicts that mistake every time it moves. It does not experience past or future. It connects events without aging between them. It reveals that what feels like an unfolding sequence may, at a deeper level, be a geometric relationship. And if time is not flowing the way you think, then reality is not unfolding the way you think either. Light is not simply traveling through the universe. It is outlining the limits of how time itself is allowed to exist. If light does not experience time the way we do, and if it traces the boundary of space-time itself, then its role is far more serious than simple illumination. Light defines what can happen. Every event in the universe sits inside a structure called a light cone. Imagine a single moment, a spark, a collision, a thought. From that event, signals can travel outward at the speed of light. Those signals carve out a boundary in space-time. Inside that expanding boundary lie all events that can possibly be influenced by the original one. Outside it lies permanent separation. Nothing can outrun that boundary. This is not a technological limitation. It is not about energy or engineering. It is geometric. The structure of space-time only allows cause and effect to connect within that cone. If something were to travel faster than light, it would step outside this architecture. It could reach events that should not yet be reachable. In some frames of reference, it would appear to arrive before it was sent. Cause would follow effect. Sequences would invert. The universe avoids this, not by force but by design. Light's constant speed ensures that all observers, regardless of motion, agree on the fundamental ordering of cause and effect within their light cones. They may disagree about durations or distances. They may slice time differently, but they will not disagree about whether one event could have influenced another. This preservation of causality is not optional. Without it, physics becomes inconsistent. Predictability collapses. The structure of interaction dissolves. What is remarkable is that light does not merely respect this structure, it creates it. The speed of light is the conversion factor between space and time. It determines the angle of every light cone. Change that speed, and you reshape the entire causal architecture of the universe. Signals would propagate differently. Forces would reorganize. The boundaries between possible and impossible influence would shift. Reality would not just look different. It would function differently. This is why light's constancy feels so rigid. It is holding together the logical skeleton of the cosmos. When you send a signal across a room, when gravity influences a planet, when electromagnetic forces bind atoms, all of it operates within this same boundary. The speed of light sets the maximum rate at which any change can spread. It is not just about photons. It is about information. Causality requires a limit. Without a maximum propagation speed, the distinction between before and after becomes unstable. The universe would allow contradictions. Events could influence their own past. Consistency would fracture. Light prevents that fracture simply by existing at its invariant speed. This reveals something subtle and unsettling. The universe is not built on objects first and rules second. It is built on relationships, on allowed connections between events. Light defines those connections. From our perspective, it feels as though light is racing outward from events. But from the geometric perspective of space-time, light is tracing the edges of possibility. It outlines the region where influence is allowed. Everything you have ever experienced has occurred within your past light cone. Every memory, every sensation, every piece of information arrived because light or other signals traveled within that boundary. Beyond it lies a region forever inaccessible. Not because it is hidden, but because its events cannot reach you without exceeding light's speed. The unsettling implication is that reality is not universally connected in the way we intuitively assume. It is locally connected, constrained by geometry. Light enforces that locality. And it does so silently. When you look up at the night sky, you are not seeing a simultaneous universe. You are seeing a layered structure of light cones intersecting your own. Some stars you observe may no longer exist. Their light reached you because it was allowed within your causal boundary. Light is not merely traveling through space. It is defining which parts of the universe are causally accessible to you at all. That is the hidden architecture you were never meant to notice. Because at human scales it feels seamless, continuous, open. But beneath that seamlessness lies a rigid geometric constraint, a boundary that cannot be crossed without unraveling the consistency of existence itself. Light is not simply illuminating the universe. It is holding its causal structure in place. By now, light no longer looks ordinary. It does not simply brighten rooms or carry images to your eyes. It explores every possible path. It does not experience time. It defines the boundary of causality. It quietly holds together the logical structure of the universe. And yet you were never meant to notice any of it. Not because it is hidden behind secrecy, but because your scale smooths it out. At human speeds and human distances, the probabilistic paths cancel into straight lines. Time dilation shrinks into invisibility. Light cones feel like open space. The geometry of space-time averages itself into something that looks solid and continuous. Your senses evolved for survival, not for fundamental physics. You perceive surfaces as firm, objects as stable, time as flowing. These perceptions are not lies. They are approximations. They are what reality looks like when quantum interference and relativistic geometry are operating far beyond the range you can directly feel. Light exposes that approximation. Every beam that reflects off a wall is the result of infinite possibilities interfering into order. Every distant star you see is connected to you by a space-time boundary that defines what is causally reachable. Every color you perceive is encoded in oscillating electromagnetic fields constrained by a universal speed limit. The world feels solid because the deeper fluctuations cancel themselves at your scale. But the cancellation does not erase what is happening underneath. This is the quiet truth. Reality is not fundamentally solid, not fundamentally linear, not fundamentally continuous in the way it appears. It is geometric and probabilistic at its core. Light makes that structure visible. If you look closely enough, when you flip on a lamp, it feels immediate. But that immediacy is not simplicity. It is the result of space-time being structured so tightly that causal relationships remain consistent at every scale. When you see across a room, you are not witnessing a static scene. You are receiving a network of light paths that have resolved from countless alternatives into a coherent image. When you look at the night sky, you are not observing the universe as it is now. You are intersecting with its past through the precise geometry of light cones. None of this announces itself. Light performs its deeper role silently. It maintains the structure of cause and effect. It respects the probabilistic rules of quantum behavior. It obeys the geometric limits of space-time. And it does so without ever disturbing your sense of normalcy. That is why you were never meant to notice. If the deeper structure were directly visible at everyday scales, the world would not feel stable. It would flicker with possibility. Durations would stretch and compress noticeably. The ordering of events would feel less absolute. Instead, comma. The universe allows complexity to resolve into simplicity at the scales where you live. But once you understand what light is doing, the simplicity never feels quite the same again. A beam across a room is no longer just brightness. It is the outcome of infinite paths interfering into order. A distant galaxy is no longer just a point of light. It is a causal connection stretching across space-time's rigid geometry. The ordinary dissolves into the extraordinary. Light is not simply illuminating objects. It is revealing that reality itself is structured, constrained, and far more subtle than intuition suggests. And the most unsettling part is this: it has been doing that all along, every second, everywhere, without ever asking you to notice.